Today we're going to learn about polynomials, and before we dive into polynomials, we're going to review some exponent rules that you have definitely learned or seen in Algebra 1 and Algebra 2. The good thing about most of these rules is that if you forget them, you can kind of draw them out and derive them. So let's do this. So the product rule says if I have two things with the same base, this a down here is called the base, which we learned before, they have two different powers, then you can write that as the base and then add the two powers. So for example, let's say I have a squared times a to the third. A squared means a times a, and then a cubed means a times a times a. And if I wanted to write this, this is a 5 times. 1, 2, 3, 4, 5. This is a to the fifth, which is where the rule comes from because we did 2 plus 3 to make 5. Power rule says if I have a base raised to a power and then another power, that you multiply the powers. So let's do an example. Let's say I have a squared cubed. So that means a squared 3 times. A squared, a squared, a squared. And we can go up and use our addition rule, or again, we can draw this out. So a squared means a times a times a times a, and then you count those, and that's a to the sixth. Well, over here, we could have done a to the 2 times 3 power, and that would have made a to the sixth. This rule, the power rule, says if you have a base, well, two bases actually, with a power on the outside, that they end up both getting the base. And the same idea works with a fraction, that if you have a base over a base, that they both get the base. So let's go ahead and use some of these rules. So on example A, it says I have y to the fourth times y to the seventh. And I'm going to draw them out just for the first one. So y to the fourth is 1, 2, 3, 4. Y to the seventh is 1, 2, 3, 4, 5, 6, 7. And if you add those up, which is the same thing as doing 4 plus a 7, because I have the same base with different powers, I would have got y to the 11th. So on the next one, we're multiplying. If you remember, when we multiply, we can use the associative property, and I can do it in any order that I want. I can do a times b times c, or I can do a times b times c. So I'm going to rewrite this because I'm going to put all my numbers first. So I have 6 times 9 times 2, and then I like to cross things out to keep track of them, times z to the fifth times z to the third times z squared, 5, 3, 2. Okay, I have everything there. And now I can just put things together that belong together. So my numbers belong together. So 6 times 9 is 54 times 2, 108. So this piece is 108. And then here, those all have the same base and different powers. So we add the powers up. So 5 plus 3 is 8. 8 plus 2 is 10. So this is my final answer. Squared means... Okay, let's keep trying some of these. Okay, so on this letter A, on example 2, I have a power raised to a power. So I'm going to draw it out the first time, and then I'm going to use the rules from that on out. This is the same thing as saying 5 cubed, but it's squared, so I need 2 of those. And 5 cubed is 5 times 5 times 5 times 5 times 5 times 5. This is really 5 to the 6th, which is the same thing as if we have done 5 to the 3 times 2 power, because a power raised to a power would multiply 5 to the 6th. Letter B is tricky. Everyone in the parentheses has to get that third power. So I have 3 to the 4th to the 3rd. And then I get x squared to the 3rd. And then I'm going to do this power to a power rule twice. Once right here and once right here. So 4 times 3 is 12. So I get 3 to the 12th. 2 times 3 is 6. So I get x to the 6th. At this point, I would recommend that you pause the video and you should try C and D and then come back and work them with me. Let's make sure we get the same answers. Okay, so for letter C, I have a fraction. So everyone in here has to get this third power. So on top of my fraction, I have a 2 to the 5th that then gets raised to the 3rd. On the bottom, I have b to the 4th that then gets raised to the 3rd. And then you do your power to a power rule. So I get 2 to the 15th on top over b to the 12th on bottom. Okay, D might be the trickiest of them all. So I'm going to give everyone in here, everyone gets this 5th power. So -2, parentheses around it, to the 5th. M to the 6th to the 5th. On the bottom, t squared to the 5th, z to the 5th. Okay, I'm going to write it out. -2 to the 5th, this right here, is -2 times -2 times -2 times -2 times -2. A negative times a negative makes a positive. Negative times a negative makes a positive. Positive times positive is a positive times my -2 at the end. So this is a -32. I multiply the m power, so I get m to the 30th over, multiply the t powers, t to the 10th, and then z to the 5th. So here's your final answer. Now, I'm sure one of your favorite rules is that in the non-zero real number, so that's key right here, non-zero real, that is raised to the 0th power will always equal 1. So I have 4 to the 0th, 1, because 4 is a non-zero real number. -4 is real and non-zero, so -4 to the 0th is 1. Okay, C is different. C says you have a negative, but then the 4 is raised to the 0th power. So the only thing that has the 0 on it is the 4. So 4 to the 0th is 1, and then I have the negative out front. So my answer for letter C is -1. Okay, letter D, I have the negative out front. -4 to the 0th is 1. So my answer is -1. And then, assuming R is real, everything in here is raised to the 0th. So my answer is 1. Okay, so now let's jump into polynomials. Let's talk about some vocab. Okay, so polynomials. Polynomial is the product of numbers of one or more variables raised to a power, which is called a term. So these are all called terms. The number in the front is referred to as a numerical coefficient. So numerical coefficient, or if there's frequently more used, is just coefficient. So my -13 is a coefficient, my 4 is a coefficient, and this -1 is a coefficient. And like terms have the same variables. So all of these are called like terms because they all have x cubed, and x cubed. However, these right here are unlike terms because this is a y squared, and a y to the 3rd. Those are not the same. A polynomial is a term or a finite sum of terms with positive integer non-zero exponents. So let's look at that real quick. Positive integer non-zero exponents. So 3, 2, there's a 1 here. This one had a 0 on it, so we're good. 5, 0, 2, 0. However, this, when you put the x down in the bottom, if you remember from Algebra 2, if we have x to the -1, that equals 1 over x. We send the negative down to the bottom. So this is not a polynomial because that is not positive. This is a negative exponent. The degree of the term on one variable is based on the power on the exponent. So for example, the degree of the term right here, this degree is a 3. So even though there's a 2 and a 1, it's based on the biggest power. So if I had written something like, let's make one up. So if I have written 6y squared plus 2y to the 5th minus 7y. The biggest degree here is 5, so this one's degree is a 5. One little caveat is right here. If you have something where you have multiple variables multiplied together, you can't just grab the biggest number, you have to add them up. So 4 plus 3 plus 5 is 12, so this is a degree of 12. There's a 1 hiding there, so 1 plus 2 plus 7 is 10. That one's degree is 10. We can classify polynomials. A polynomial can be classified by the number of terms, and so little language lesson. Prefix, the part in the beginning of the word, the prefix, tells you how many, and the suffix, the ending of the word that we're going to use is nomial. Nomial means terms. So we're going to put a prefix in front of this to tell us how many terms. So monomial. Mon means 1. Binomial means 2. Trinomial means 3. And then anything after a trinomial we call a polynomial because poly stands for many. So to put these things in standard form means we put them in descending degree order, meaning this right here is not in the correct order because I should have put the y to the 5th first. But this one right here is in the right order because the degrees go down on the x to the 3rd, x squared, x to the 0th. So let's try using these vocab words and classifying some polynomials. So for these examples, they want you to first say if it's a polynomial or not. And then if it is a polynomial, tell the degree and give it a name like monomial, binomial, trinomial, polynomial based on the number of terms. So if you look at letter A, my powers are 7, 3, and 2. 7, 3, or 2 are all positive integers. So yes, this is a polynomial. Since it is a polynomial, I need to identify the degree, which is the highest power, which is 7. And there are 1, 2, 3 terms, so it's a trinomial. Letter B is a polynomial or not a polynomial? It's not a polynomial. And the problem in letter B is this variable in the denominator. Letter C is a polynomial. There's no negative exponents. I got 3 and 2, so that's good. The degree, remember, because I have 2 variables here, I have to add them up. I have to do 3 plus 2, so my degree is 5. And I only have 1 term, so what do you call something that only has 1 term? That's good. Monomial. So let's keep doing some math with polynomials. Okay, so let's add and subtract some polynomials by figuring out what their like terms are. So I'm going to just rewrite this first one because I'm adding right here in the middle. I really don't need the parentheses. 2y to the 4th minus 3y squared plus y plus 4y to the 4th plus 7y squared plus 6y. this is a y to the fourth, and it has 2 of them, and this is a y to the fourth, and there's 4. So 2 of something plus 4 of the same something makes 6y to the fourth. This is a y squared, this is a y squared, so they're the same variables. One is -3, the other one is a +7. So -3 of something plus 7 of that same something make a +4y squared. And then a y plus 6 more y makes a +7y. So there's your answer. Let's try the next one. The next one's a little bit trickier because of this minus sign. So the first thing I like to do is distribute the negative into the parentheses and change all the signs. So I get a -3m to the third minus 8m squared plus 4. And then this becomes a -m cubed minus 7m squared. A negative makes this a +3. And then we do the same thing we just did. We combine like terms. So this is an m cubed, or m to the third, and this is another m to the third. -3 minus 1 more makes a -4m to the third. -8m squared minus 7m squared makes a -15m squared. 4 plus 3 is a +7. This is your final answer. Let's try another one. This one has the plus sign in the middle, so you can just rewrite it. 8m to the fourth, p to the fifth, minus 9m to the third, p to the fifth, plus 11m to the fourth, p to the fifth, plus 15m to the third, p to the fifth. Now I just need to be a little bit careful. There's 2 variables, so the power on the 2 variables has to be exactly the same for each variable. So for example, this is m to the fourth, p to the fifth, m to the fourth, p to the fifth. And when you combine those 2, that gives you 19m to the fourth, p to the fifths. This is m to the third, p to the fifth, and this is m to the third, p to the fifth. So those 2 go together. They're exactly the same variables. -9 of something plus 15 of something makes +6 m to the third, p to the fifth. One last example of adding and subtracting with a distributive property. So first things first, not only am I going to distribute a 5 in, I'm going to distribute the -5 in. So let me copy it on the first part. Oh, and a 4. 4 out front. So let's do the first part. When I distribute the 4 in, I get 4x squared. 4 times -3 is -12x. And then 4 times 7 is +28. Now this piece, you're going to distribute the -5 in. So you're going to get -10x squared. A negative times a negative is a positive, so +40x. And then a negative times a negative is a +20. And now we can combine our like terms. X squareds with x squareds, 4x squareds minus 10x squareds is -6x squared. -12x plus 40x makes a +28x. 28 plus 20 makes a +48. And here's our final answer. Now we're going to multiply. I know some of you, when you learned to multiply, did FOIL, which is absolutely fine. I'm going to do the method that I use, and then I'm going to show you something that I think you learned in Algebra 2. So what I do, or I think in my head, I make everyone friends. So my 3p squared needs to be friends with everyone in the other set of parentheses. So 3p squared needs to be friends with p cubed, with 2p and with -8. So I'm going to do that first. So 3p squared times a p cubed makes a 3p to the 5th. 3p squared times the second line right here, this one right here, times 2p makes a plus 6p cubed. And then 3p squared times -8 is a negative 24p squared. And I just want to go over here for a second. If you don't know where the powers are coming from, so I did 3p squared, and then I multiplied on the first line that times p cubed. So you can use your exponent rules and you can add those exponents, or if you don't see it, p squared means p times p, and then p cubed is 3 more p's. And then there's 1, 2, 3, 4, 5 of those. I'm definitely not done yet, because what I need to do now is I need to make the next term friends with everyone. So I'm going to take my negative, don't forget the negative, I'm going to take the negative 4p, and I'm going to make it friends with the p to the third, the 2p, and the -8. So that's going to give me a negative times a positive is going to be a negative 4p to the 4th. A negative times a positive is going to be a negative 8p squared. And then a negative times a negative is actually going to make me a positive and make me a plus 32p. And I have to do this one more time. I have to make the 1 friends with everyone. Well, that's easy because 1 times anything is the other thing. So plus p cubed plus 2p minus 8. Now we have to go in and combine like terms, because if that wasn't enough work, now we have to clean it back up. So look for the biggest power. Here's my biggest power. So I get 3p to the 5th. I like to underline or cross things out as I use them so I can keep track of it. If I start with p to the 5th, now I should go to p to the 4th. Here's my only p to the 4th, so minus 4p to the 4th. And then to the 3rd, well, here's a 6p to the 3rd, and down here there's 1 more. So 6p to the 3rd plus 1 more makes plus 7p to the 3rd. And then squareds, I have negative 24 here and -8 here, which makes negative 32p squared. And then right here, I have 32p, and then right here, 2 more p's makes plus 34p. And all that's left down here is my -8. And this long thing is your final answer. Okay, so that's how I learned to do this, but some of you might have learned what's called the box method. So draw a box. And because my first set of parentheses has 3, you need 3 columns. So you do 3p squared negative 4p and then a 1. And if you want to put your plus signs in, you can, because those are positive. And then the second set of parentheses also has 3 terms, so I need 3 rows. And you do p to the 3rd, 2p, and then -8. And then you multiply into your boxes. So for example, this box that I'm highlighting in yellow touches 3p squared and p to the 3rd, which makes my 3p to the 5th. The next one, I'm going to multiply negative 4p and right here 3p, which makes negative 4p to the 4th. And then the next one, I'm going to do 1 times 3p to the 3rd, and you get p to the 3rd. And then when we go down to this red box, we're going to use the top term and this term right here. So 3 times 2 is 6, and p squared times p is p to the 3rd. We keep going. Negative 4 times 2 is -8. P times p is p squared. And then 2p times 1 is 2p. This box right here, 3p squared and -8, so we get -8p squared. 4p times -8 is 32p, and then 1 times -8 is -8. And we combine like terms. So this is, instead of underlining, in this case I circled them. So I have 3p to the 5th, 3p to the 5th. Then I go look for my 4th powers, which is right here, minus 4p to the 4th. I look for my 3rd powers now. So right here, 6p to the 3rd, and then 1 more p to the 3rd makes my plus 7p to the 3rd. Then I look for my squares. I just realized I made a mistake. Let me go back right here. 3 times 24 is not negative 8. 3 times 24 is 3 times 8 is negative 24. Okay, so now my squares is negative 24p squared and negative 8p squared, which makes negative 32p squared. And then p and p makes plus 34p, and then my minus 8. And then this box answer is the same thing we had right here. So either way, you can do that. So we're going to use FOIL, something you learned hopefully in Algebra 2 and even Algebra 1. Before we do, let's write down what FOIL stands for. So FOIL is an acronym that we use in math to multiply binomials, things with 2 terms in them. So FOIL stands for the firsts, then the outsides, and then the insides, and then the lasts. So we're just zoom in right here. We're going to do this. So let me write down the letters of FOIL real quick so I can color code this for you. So it says to use FOIL. So F stands for my first. So you take the first from the first binomial, multiply it with the first and the second binomial. 6 times 4 is 24, and m times m is called m squared. O stands for the outside one. So you take the outside. So this is on the outside, and this is on the outside, and you multiply those together. So 6 times negative 3 is negative 18, and then m. Insides mean that you take the inner two, you multiply those together, so you get plus 4m. And the L stands for the last, so you take your last one from your first binomial and the last one from your second binomial, and 1 times negative 3 is negative 3. And then we just have to clean it up and combine like terms, so I get my 24m squared. These two terms need to go together, giving you a negative 14m, and then minus 3. So there is our answer. So we're going to FOIL again. This one I'll put a little star by. It's a special pattern that we're going to talk more about in a second, but just wanted to put that next to it so you can remember it later. So first, get me my 4x squared. Outsides, get me a negative 14x. Insides, get me a positive 14x. And my last, get me a minus 49. The 14x's have opposite signs, so they'll cancel off. So this is 4x squared minus 49. Okay. This last one, we're not going to forget about this guy up front, okay? We're going to do that last, but we're going to do first multiplication of the two binomials. So I'm going to do my first. I'm going to get 9r squared. And then I'm going to do my outsides. So 3r times negative 2 is negative 6r. Then I'm going to do my insides and get plus 6r. Then I'm going to do my last right here like this and get minus 4. I'm not going to forget about that circled r squared, but first I'm going to combine like terms. So I get 9r squared minus 4. And then I'm going to drop down my r squared. So this r squared has to get distributed in like this. So you're going to get 9r to the 4th minus 4r squared. This starred one right here. This is a very special factoring pattern and multiplication pattern. So on the previous page, I said that we're going to hold on to something, so let me go back. It's called product of the sum and difference of two squares. So let me zoom in for you. So the whole idea to this magic factoring pattern, which I think in Algebra 2 you called the difference of two squares, which is what we call it down here. So it says product, which means we're multiplying. So let me just code the word for you. So it says product. That means we're going to multiply of the sum and difference. So sum means that one set is plus, and difference means that one set is minus. And it says of two terms, which means those two terms we're going to keep the same. So let's call my two terms, they used x, y, I'm going to call them a and b. So a and b. So you have the product of two binomials with two terms in them. That's why they're called binomials, a and b, a and b. One is a plus and one is a minus. I'm going to multiply this out to prove you what happens. So if I do a times a is a squared. A times negative b is negative ab. B times a is a plus ab. I like to write things in alphabetical order. So ba is the same thing as a times b. And then b times negative b is a negative b squared. These two are going to cancel off, which leaves us with a squared minus b squared, which is what's right here, the x squared minus y squared. So let's use that pattern on the first three, and then we can look at the other pattern in the box. So if I go to do this first problem, here's my a and my b, and these were adding. Here's my a and my b. They were subtracting, so you should recognize the pattern, and you should know this is going to equal a squared minus b squared. So 3p was what my a was called, and a is squared, so I put the square on the outside, minus b was called 11. And remember, it's minus b squared. And then you just have to be very careful with your exponents. In this first one right here, 3p and then squared means they both get squared. So this is going to be 9p squared. And then minus 11 squared is 121. The other thing you can do is you can actually just FOIL it out, because you should still get this as your final answer. So let's try another one. Try the next one. Here's my a, my b. So this thing should equal a squared minus b squared, because remember right here I have a minus b and then a plus b. So a is 5m cubed, then squared, minus b up here is 3 squared. So be careful. 5 squared is 25. M cubed raised to the second power means you multiply, so you get m to the 6th minus 9. Here's my a minus b. Here's my a plus b. So my a is 9k. My b is negative 11. Oh, sorry, just so we call it 11r cubed. So then I'm going to do a squared minus b squared. So I'm going to have 9k squared minus 11r cubed squared. So this becomes 81k squared minus 121r to the 6th. Oops, r to the 6th. So let's go back up and look at this other factoring pattern that we didn't talk about yet. It's a square of a binomial. So if you take a binomial, two terms, and you put a square on the outside, either a plus or a minus version. I'm going to show you we'll do the plus version first. So that means x plus y times x plus y. So when you FOIL, you get x times x is x squared, x times y. I always write them in alphabetical order. Y times x, but again, alphabetical order, so I'm going to write xy, because 1 times 2 is the same thing as 2 times 1. And then y times y. Then these two combine, y times y is y squared. These two combine, so you get x squared plus 2xy plus y squared. And when you do the minus version, everything's the same except for right here, it's a minus. So, go down to the bottom. These are all squares of binomials, and so the pattern is the following. you have some binomial x, y. It's going to equal the first one squared, 2, and then each of them multiplied together, and then y squared. If this is a plus, then it's a plus and a plus. But if this was a minus, it's a minus and a plus. So it's just this one right here that changes. So let's go ahead and do 2m plus 5 squared, which means 2m plus 5 times 2m plus 5. But because right here this is a binomial square, we can use our pattern. We can do this thing is x, this is y. So I can do x squared, and then it's a plus. So plus 2xy plus y squared. So I'm going to replace my items in. I didn't have an x. My x is called 2m squared plus 2 times 2m times 5 plus 5 squared. Remember, we talked about this in an earlier video. When you plug items in, you always need to put parentheses around them, so we don't have any plus or minus sign errors. 2m squared is a 4 because they both have to get squared. So 2 squared is 4, and then m squared plus 2 times 2 times 5 is 20m plus 5 squared is 25. And you can go ahead and pause the video if you want and verify this by foiling, but you will get the exact same answer. Okay, so the next one. So this whole thing is my x term, and this whole thing is my y term. So remember, the pattern is x, 2xy, and then y squared. And then because there's a minus here, this is a minus, and this one's always a plus. So then we're going to plug our stuff in. My x was actually called a 3. Oops. Sorry, I meant to go back to black. My x was actually called a 3x. Oh, this one was squared. 3x squared minus 2 times x was called 3x, and y is called 7y to the 4th, plus y is called 7y to the 4th, and then we have to square it. 3 squared is 9, and then x squared minus 2 times 3 is 6, times a 7 is 42 x, y to the 4th. Remember, we always write the letters in alphabetical order. And then plus the 7 gets squared, so 49 y to the, remember these get multiplied, so 4 times 2 is 8. Okay, on the next page, we're going to keep multiplying. Don't let the brackets freak you out. They are just, when we have 2 sets of parentheses, sometimes we use a set of brackets instead of parentheses. So this is the difference of 2 squares. This is an x plus a y times an x minus a y, which from the previous page equals x squared minus y squared. Now, if you didn't see that right away, by all means, you could FOIL. So you could do the first times the outsides times the insides times the last. That'll get you the same answer. Another option is, actually, hold on to that. We're going to do the pattern first, and then I'm going to show you the other option. So the beauty of this is that, yes, in math, there's only one right answer, but there are multiple ways to get to that right answer. So let's go ahead and recognize our pattern, and so I'm going to do what I did here in red. So if I say that 3p minus 2 is x, so this is going to be 3p minus 2 squared minus 5q squared. So this means that I have to do 3p minus 2 times 3p minus 2, which is another pattern, but I'm going to take care of this first, minus 25q squared. This is the pattern we use on the previous example where we have x minus y squared, and it becomes an x squared minus a 2xy plus a y squared. So my x here is called 3p squared minus 2 times 3p times 2 plus 2 squared. So this is going to get me 9, because 3 squared is 9, p squared, minus 2 times 3 is 6, times 2 more is 12p, plus 4, and then don't forget about this down here and drop him, minus 25q squared. If you wanted to FOIL it out, you could, but this one I used 2 patterns and got there just a little bit quicker. The next one, I'm going to rewrite this. I'm going to write this as x plus y squared times x plus y, which is really to the first. And then because these are the same, you can add the powers and get back to the 3 right here. But this in and of itself is a pattern. This is x squared plus 2xy plus y squared. And then I just have to multiply in my x plus y. So what I'm going to do is I'm just going to make everyone friends. I'm going to take the x squared and send him to both, getting me an x squared plus an x squared y. I'm going to send the 2xy to both, getting me a 2x squared y plus a 2xy squared. And I'm going to send the y squared to both, getting me xy squared plus a y cubed. Please note that I wrote all these terms in alphabetical order. So if I had an x and a y, I always wrote the x first. It helps a lot when you're combining like terms. And I already made a mistake. Let me go fix that. Right here, this should be a cubed. X squared times an x squared times an x is an x cubed. Okay, so let's do this. So I have my x cubed, so taking care of x cubed, plus x squared y, 2x squared y's, which makes 3x squared y's, 2xy squared plus another xy squared makes 3xy squareds plus the y cubed. Okay, let's do another one. We're going to write this one again. Oops. I can write this as 2a plus b squared times 2a plus b squared. And then I can apply the pattern to this and the exact same pattern to this. This is my x plus y squared, which is x squared plus 2xy plus y squared. So it's going to be a 2a squared plus 2 times 2a times b plus a b squared, which is 4a squared plus 4ab plus b squared. Because these two green underlined things are exactly the same, I actually have 2 of them. So here's the red one right here, and the blue one would have been exactly the same. 4a squared plus 4ab plus b squared. And then what I'm going to do is I'm going to FOIL this out. Well, not FOIL, but I'm going to distribute this all out. You can do the box that we did earlier or not. I'm just going to do 4a times 4a squared, 4a squared times 4ab, and do 4a squared times b squared. So when I do that, I'm going to get 16a to the 4th plus 16a cubed b plus 4a squared b squared. And then I'm going to keep going. I'm going to do this 4a squared to everything in here like this. So you get plus 16a cubed b plus 16a squared b squared plus 4ab cubed. Then one last time, you take the last term and send it to everyone. I know it's so long. 4a squared b squared plus 4ab cubed plus a b to the 3rd. And now we're just going to clean it up. So start with your biggest powers of a. So I'm going to start with a to the fourth. So I have 16a to the fourth. Oops. Now find your a to the thirds. So this is a to the third b, a to the third b. So that should be 32a to the third b's. And then your a squared. So there's 4a squared b squareds, 4a squared b squareds. And then down here, 4 more a squared b squared. So 4 and 4 is 8. 8 and 16 is 24 a squared b squareds. And then I have my b to the thirds. So 4 ab cubes plus 4 more ab cubes makes 8 ab cubes plus b to the fourth. And all the work that we're showing on the paper needs to be on your paper as well. And now that we have added, subtracted, and multiplied polynomials, we should also divide them. So let's go ahead and do that. So dividing polynomials have a couple of rules. So before you do anything, one, put the terms in order. And 2, add in 0 for the missing terms. And so by order, what I mean is if you look at the first one, this is an m to the third, an m to the second, an m to the first, and then an m to the 0th. These are in descending order. And by adding the missing ones, I'm not missing anyone. 3, 2, 1, none. But if I went 3, 1, none, I'd be missing this square term, and I would add in a 0 for that. So on the first one, nothing's missing, and you also need to check your other polynomial. Nothing is missing here, and it's in order. So once we check those, then we can do the problem. So we're going to do 2m minus 1 long divide 4m cubed minus 8m squared plus 5m plus 6. Okay, to do this, you really just take your first term. So here's my first term, and here's my first term. And I'm going to ask the question, what do I need to multiply this one by to get to this one? So the answer to that question is to make a 2 become a 4, you need to multiply by a 2. And to make an m become an m cubed, you need an m squared. So I go above my m squareds, and I need a 2m squared because the square and the square right here should be in the same place. Now, if you couldn't figure out what to multiply by, you also could go over here and do 4m cubed divided by 2m. 4 divided by 2 is 2. This is m to the first. So m to the third divided by m to the first. 1, 2, 3. Divided by 1, they cross off, gets an m squared, which is where I got this term from right there. Then you have to multiply this term right here times everything out here. So 2m squared times 2m makes a 4m cubed, and that should always happen. It should match up. 2m squared times minus 1 is minus 2m squared. Then you have to subtract the entire quantity. So I'm going to change to a plus. I'm going to distribute the negative in here. And then we add. When you add these two together, if you did it all right, they should always cancel off. The first one should cancel off. Negative 8m squared plus 2m squared makes negative 6m squared. Then you drop down your next term, plus 5m. Repeat the process. How do you make your first term here, 2m, become a negative 6m? We'll need to multiply by a negative 3, and m times an m makes that m squared. M times 2m is a negative 6m squared. Again, those should match. Negative 1 times negative 3 makes a plus 3m. Then we subtract the entire thing, which makes this become a plus and a minus. These two, a negative 6m squared plus a 6m squared, cancel off. 5m minus 3m is a 2m. And then you drop down the 6. One more time. To make this 2m become this 2m, you multiply by a plus 1. 1 times 2m is 2m. 1 times negative 1 is a minus 1. Subtract the whole thing. Distribute the negative sign into it. 2m minus 2m is nothing. And then 6 plus 1 is 7. This is my remainder. So I go up here and I write plus 7, whatever the remainder was, over whatever you were dividing by over here. 2m minus 1. So this right here is your answer. Try one more time. So before I set this up, I'm just going to check. Are they in order? 3, 2, uh-oh, I'm missing one here. I'm missing just the x term. And then here, x squared, but I'm missing the x term here as well. So let me rewrite the problem before I even do any math. This is really 3x to the third minus 2x squared plus 0x's minus 150. And then we're going to divide this by x squared plus 0x minus 4. So now that we have it in order and we've put in our missing terms, we can reassign this. So let's set the problem up. We get x squared plus 0x minus 4. And then we're going to do 3x cubed minus 2x squared plus 0x minus 150. To make my x squared become a 3x cubed, I need to multiply by a 3x. And again, see how my x's right here are in the same place. 3x times x squared is a 3x cubed. 3x times 0x is a 0x squared. 3x times minus 4 is minus 12x. Subtract the entire thing. So add opposite, opposite, opposite. The first ones cancel out. Negative 2 minus nothing is still negative 2x squared. 0 plus 12 is plus 12x. Drop down your missing or your next term. And then you do it again. How do I make x squared become a negative 2x squared? You multiply by a negative 2. And you get negative 2x squared plus 0x plus 8. Subtract the entire thing. So distribute that negative sign inside. The first ones cancel out. 12x plus nothing is 12x. 150, or negative 150 minus another, or no, sorry, plus an 8 is going to make a negative, no, sorry, plus a negative 8. It's going to make a negative 158. Since this has a smaller degree than this is my remainder. So plus 12x minus 158 over x squared minus 4. Here's your answer.